Hey everybody, we're going to be talking about absolute value today. So absolute value of a number is its distance from 0 on the number line. Whenever we take the absolute value of a number, when we're trying to find the distance from 0, all distances are positive. You don't say something is like -5 miles away. So whenever we take the absolute value of something, it becomes positive. When you have something inside the absolute value, you're going to simplify that first and then take the absolute value. So 1 minus 2 is -1. The absolute value of -1 is 1. -3, and then this would become a +5 is 2. So this would be 2. -2 times 3 is -6. So this would be 6. 0 times 4 is 0. The absolute value of 0 is just 0. 12 divided by -3 is -4, and the absolute value of that is 4. And then 8 divided by -4 is -2. The absolute value of that is 2. So whenever you take the absolute value, it becomes a positive number. If we graph a line, okay, this is our basic line, so it has a slope of 1 and a y-intercept of 0. So if I plug in x, it just equals y. Like nothing is happening here. There's no multiplication, no adding. So whatever you plug in, you're going to get that out. And like I said, this is just a line. So if I were to graph this, it would look a little something like that. And then of course I can connect my dots to actually form the line. Okay, now when we take the absolute value of an input, it's always going to become positive. So if we take the absolute value of -9, it's going to become 9. Absolute value of -6 becomes 6, and so on. So this one's going to look slightly different. But it is going to line up with part of our line. And if I connect these dots, notice that I have a V shape. Now this V shape, what's interesting about it is it's two lines that are basically meeting. So they both have a slope, okay? If you notice, the slope of this particular line that we graphed was up 1/1. So the slope of this part is 1, the slope of this part is 1. So it's just two lines going in opposite directions. Something else you'll notice about this is it has a minimum. So it has a piece that is decreasing and increasing. Oops. And again, it's like two lines put together. If you need to pause this video and make sure you have all that down, feel free to do that. You do not have to go at the pace that I am going. Well, what happens if I do a -x? So this is going to be a line with a negative slope. So I am going to essentially make all my negatives positive and all my positives negative. And you'll notice this is a decreasing line. Still going to have a slope of 1. It's just going to be a slope of -1. Oh, that was almost perfect there. Now, if we turn this into an absolute value, it really doesn't matter what the sign is inside that absolute value. because whenever we take the absolute value, it's going to turn positive, okay? So if we take the absolute value of -9, that's going to become still everything positive. So this time, when we graph it, different sides are going to line up with each other. So we are going to line up with this side, but we are also going to line up differently over here. So if you compare the first, it lined up with the positive side, and this one lines up with the negative side. So like I said, they both have slopes. One is going to be that negative side and one's going to be that positive side. It's two lines that are meeting together. And again, we have a minimum and an increasing and decreasing section. Again, if you want to pause this video, feel free to do that. We're going to use technology here to graph these, okay? So I'm going to pull up Desmos. And I'm going to start with just the absolute value of x. So y equals absolute value of x. So there it is. It's that V shape. We've got two lines meeting. They both have a slope of 1. Just this one is the negative side. This one's the positive side. But what happens when I add 3? So if you notice, the slope didn't change because this is still going 1, 1, 1, 1, 1, 1. However, this minimum has moved up 3. What's going to happen if I do -3? Again, there's still a slope of 1 over 1, 1 over 1, 1 over 1, but the minimum has now moved down 3. So this is the basic. Adding 3 on the end moves it up 3, and subtracting 3 on the end moves it down 3. So our basic one, up 1 over 1, it's going to be this one. If I add 3, I'm going to move everything up 3. And if I subtract 3, I'm going to move anything down 3. It's kind of like moving the y-intercept when we graphed lines. So basically we've moved the minimum, and that minimum actually has a specific name. It's called the vertex. So if you see something being added or subtracted, if it's added on the end, it's going to move up. If it's subtracted on the end, it's going to move down. Again, you can pause this video if you need to. So now I'm going to look at these. So I have x, a 2 in front, a 1/2, and a -1. I want you to think about how those kind of look like maybe slope, right? Slope is in front of x. So the first one was just the basic, right? Up 1 over 1. What happens if I put a 2 in front? That's definitely different, right? The minimum, the vertex didn't move. However, my slope is up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And it's up 2 over 1 to the left as well. What happens if I put a 1/2 in front? So the minimum didn't move, the vertex didn't move. Instead, I'm going up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Notice as well that this green graph is definitely a lot wider and the blue graph is skinnier. So if you have a bigger number in front, the graph is going to get skinny. And if you have a fraction or decimal, something between 0 and 1 in front, it's going to get wide. Now watch what happens if I put a negative. This is going in a different direction now. And instead of going up 1 over 1, it's going down 1 over 1. So it has a negative slope. So the parent, up 1 over 1. If I put a 2 in front, it's going to become up 2 over 1. And it gets skinny. A 1/2 is going to go up 1 over 2. And it gets wide. The negative is going to face a different direction. Instead of a minimum, it now has a maximum. So it's opening down. So the vertex is still in the same spot though. And that word is called reflection. So the number in front is going to affect the slope of the two lines that are meeting to form this absolute value function. When you think about y equals mx plus b, that's kind of the same deal, right? The slope is in front of x. And then you have something added or subtracted on the end to move the y-intercept. Well, if we add something on the end, it's going to move up. And if we subtract something on the end, it's going to move down. So if you need to watch this video again, you can. I will be back tomorrow, hopefully, and I will see you guys then.